In this video, we look at some calculations to do with the binomial distribution. So, looking at an example, Jo shoots an arrow at a target. The probability of her hitting it is 0.6 every time she shoots. Suppose she has 50 shots. We want to know what's the probability that she hits the target less than 30 times out of those 50. Now, we can tackle this problem in two ways. One, we can use the ideas of binomial distribution. So, what have we got here? It's a binomial distribution because there's an outcome, a hit or a miss. There's a large number of trials and so on. So there are 50 trials. Let's write that down. N equals 50. For each individual arrow that she shoots, probability of a success of hitting it is 0.6. So we're after the probability that she gets less than 30. Now, because the binomial distribution is discrete, we actually want, when we use our graphics calculator, the probability of less than or equal to 29. We're going to have to put in here, if it's less than 30, it has to be 9 hits as maximum. So, how do we do this on a Casio graphics calculator? If we bring up our calculator, we go into the statistics mode, and we're dealing with a distribution. BNM stands for binomial, and we're dealing with a cumulative thing, so it's BCD. We want any number of hits from 0 up to 29, so this is the one we use. And then we have to put in our data. X here is 29, the maximum number of hits that we can have. The number of trials we had was 50. The probability of success is 0.6. And then if we hit XE and XE again, we see the probability of hitting the target less than 30 times is 0.44 rounded off to 2 decimal places. So let's write that down here and say it in words. The probability of less than 30 hits is 0.44. There's one way of doing it using binomial distribution ideas. But there's another way we can do it, and that is using the approximation to a normal distribution. Let's see what that means. Thinking about the problem again, yes, there are 50 trials. The probability of success on each one is 0.6. In this one, we need to know one take P, the probability of a miss, which of course is 0.4. And now, to check that we can use the normal approximation, we need to check out two things. We have to see that NP is greater than 10. Well, NP is 50 times 0.6, which is 30. That's certainly greater than 10. Likewise, we have to check out to see that N, 1 take P, is greater than 10. Well, N is 50, 1 take P is 0.4, 50 times 0.4 is 20, which is greater than 10. So both these conditions hold. So in this case, the binomial distribution can be approximated by a normal distribution. So what's the mean and the standard deviation? The mean is given by NP. So NP, 50 times 0.6, we've already worked out in our head, is 30. The standard deviation of the equivalent normal distribution is given by this formula, the square root of NPQ. So it's 50 times 0.6 times 0.4, and then take the square root. And if you do that on your calculator, you'll see it's 3.464. So now on the graphics calculator, we can use the normal distribution. Let's bring our calculator up again. Go back into the statistics mode. Distribution, yes. This time we're going to use the normal distribution. It's NCD. Now, the lower value here is the lowest value we can put into our calculator, so negative e to 99. Now, the highest value is a little bit tricky because the normal distribution is continuous. Remember that we want probability of less than 30, in other words, less than or equal to 29. For a continuous distribution, 29.5, anything below 29.5, would be rounded off to 29. So we must be careful that we put in here anything that will be rounded down. Actually, 29.5 itself wouldn't be, but we can put that in as a good approximation. Now, we need to put in sigma, the standard deviation, 3.464, and we need to put in the mean. The equivalent mean is 30. hit exe, next screen, and we see the probability is 0.44. The two decimal places anyway, the same as what we had before. So the probability of less than 30 hits is 0.44. So there it is, that problem done in two ways, and pretty close we get the same answer.